Complex numbers part 3. And the only operation over complex numbers that we have not talked about yet was exponents, or powers. In the last video, we learned how to add, subtract, and multiply and divide these. So again, all we have left to do is figure out how the exponents work here. Alright, I have started with the first few exponents on I to see how this all works out. Well, we know that I to the first power is just I in itself, and that is the square root of -1. I squared. What we do is we take I times I, or I times itself, twice. Well, if we did that, we know that that's the square root of -1 times itself twice, and the square root and the square cancels out, and that just leaves us with -1. So those are the two things that we've already known. We learned that in the last two videos. Let's see how this works with the rest of them. I cubed. Well, that is I times itself 3 times. Well, let me group it in a fashion where I wrote it as I squared times I. I grouped it that way because I just learned from my last step here that I squared is -1. So I'm going to write this as -1 times I. My -1 times I just simplifies to -I. So now I know that I cubed simplifies into a -I. I to the 4th. I have 4 i's, I times itself 4 times, and I can split this up however I would like. I'm going to write it as I squared times I squared, because I know that I squared simplifies to -1 again. That gives me -1 times -1. And negative times a negative is positive, and 1 times 1 gives you a positive 1. So we have finished the first 4 powers of I. But we need to keep going. We need to see what keeps happening with these. I to the 5th. That's 5 of them. I can write it in any sort of way that I want. I'm going to split it as I to the 4th times an I. And the reason that I did that was because that we just learned that I to the 4th simplifies as 1. So this is 1 times I. And 1 times I gives you I in itself. Okay. So we start to see how some of these works out. So you might want to pause the video and see if you can figure out the rest of these at this point. I to the 6th. I can break that down any ways that I want. I'm going to split it as I to the 4th times I squared. I to the 4th we know simplifies to 1, and I squared simplifies to be -1. 1 times -1 gives me a -1. I to the 7th. Let me split it as I to the 4th times I to the 3rd. If we look back over here on the left, we have all of these that we can use over here. So I to the 4th, we know that that simplifies as 1. And I to the 3rd, that simplifies as a -I. So 1 times -I gives me a -I. I to the 4th, I to the 8th, I can write that as I to the 4th times I to the 4th. That's 1 times 1, which gives me 1. At this point, you should start to see a pattern. If we look at these, if we look at I to the 1st power, that simplifies as just I in itself, and I to the 5th simplifies as just I in itself. If we look at I squared, that gives you to the -1. I to the 6th gives you to the -1. I to the 3rd, that's -I. I to the 7th is -I. I to the 4th, that gives us 1, and I to the 8th gives us 1. So notice we have the same type of pattern over and over here. So I to the 9th is going to fit my first bill, with the yellow one, which is I. I to the 10th is my green one, which is -1. I to the 11th is my blue one, which is negative I. And I to the fourth is my purple one, which is just 1. So we know that these all follow the same pattern. So when we have I to any power, it's only going to fit one of these answers. The only possibility that we have is plus or minus 1 or plus or minus I. Notice the only times that we end up with 1 is when our power is even. And notice we only end up with I if our power is odd. So if it's even, we have to figure out whether it's a positive or a negative 1. And if it's odd, we have to figure out whether it's a positive or a negative I. Now, the easiest ones of these to work with are the powers of 4, because those break down as 1. And we know that 1 is a very easy number to work with. So that's what we're going to use when it asks us to do I to random powers, such as these here. Now we could keep writing down the pattern of the i's to the powers before, but if we had I to like the 287th, you wouldn't want to have to write it down that many times. So there's actually an easier way to do this. And that goes back to that we know that the first 4 patterns. I stays as itself, I squared simplifies as negative 1, I cubed simplifies as negative I, and I to the fourth simplifies as 1. And the one that I'm going to always try and boil down to is I to the fourth, because again, 1 is a very easy number to work with. So this one here and all of the ones, I'm actually going to write it as I to the fourth, and I want to figure out times what power gives us here. This one actually works out very easy because it comes out very easy. 48 divided by 4 comes out even. 48 divided by 4 comes out to be 12. If you go back to your exponent properties, remember when you have a power to a power, you multiply them. So 4 times 12 does give me I to the 48. Now the reason that I broke it like that, because let me simplify the inside first. And we know that I to the fourth gives me 1. So we have 1 to the 12th power. 1 to any power always simplifies to be 1. So my I to the 48th simplifies down to be a positive 1. And we knew that it should be positive or negative 1 because it's even. We just had to figure out whether it's positive or negative. Number 2, we're going to do the exact same way. I want to break it down as powers of 4. Okay, but 23 does not divide by 4 evenly. What I want to do is I want to split it off into the thing that does divide by 4 evenly. The highest one that goes into that is I to the 20th. That leaves me with 3 i's left over. And remember, when I have this format here, you add these. So 20 plus 3 does give me a 23. So I to the 20th. I can write that as a power of 4. That's what I'm trying to do, is break these down as power of 4. 4 times 5 gives me 20. Again, remember, when we have a power to a power, that multiplies to give us 20. And we still have that I cubed left over. Now, I can simplify what I to the fourth is, and I can simplify what I to the third is. I to the fourth is a positive 1, and that is to the 5th power. And I to the third, looking up here, up top, I to the third simplifies as negative I. So simplifying these, 1 to the 5th power is 1 times my negative I, and 1 times negative I does give me a negative I. So I to the 23rd simplifies as negative I. And I knew that it should be an I because I had an odd one. Example 3. Try and do that one on your own using the techniques that we just did in example 1 and example 2. Okay, the first thing that we want to do is we want to figure out how many times does 4 go into 50 evenly. If you type in your calculator 50 divided by 4, it does not come out evenly, but you figure out that you get 12.5. So that tells you how many times 4 goes in there evenly. So this is I to the 4th, and that gives me 12 times. Now I to the 4th to the 12th, that is I to the 48th. So that gives me 2 i's left over. So I to the 4th is 1, and 1 to the 12th power simplifies as 1. On the right, I squared is negative 1. And my final answer, 1 times negative 1, gives me negative 1. So I to the 50th gives me a negative 1. And that's how you do exponents on I.